Okay, I'm going to continue with, this is version 2 of the test, and this is problem number 6, which is the data problem. Um, this problem gave a lot of people some real trouble, so we're going to go through it. Now, you could start by graphing this, plotting all these points on the graph, just to verify that it looks like a sign, but since you're really being told that it's a sign, there are better ways of doing it than graphically, and we're going to do this analytically. In other words, we're going to look at the data only. We're not even going to concern ourselves with the graph itself. And the key thing to realize, a lot of these points given are really not that important. What's important is really these two key points, where the x is, where the y is minimum and the y is maximum. And I took the time to rewrite this, isolating only those 2 points. Okay. And all right, well, from those 2 points, we realize we can get A and D values very, very quickly. They are the easiest ones to get. The A value is maximum y minus minimum y divided by 2. So 9 minus 1 divided by 2 equals 4. That's my A value. Now the D value is maximum y plus minimum y divided by 2, which is 9 plus 1 divided by 2. Now, and that simplifies to 5, so D equals 5. Those are by far the easiest things to get here. Now, B and C values are a lot more difficult to get. Now, let me see what, okay, in order to get the B value, I realize that I need, from the definition of B equals 2 pi over, well, let me start over. The period is defined to be 2 pi divided by B. Therefore, B solves to be B equals 2 pi over the period. Therefore, in order to get the B value, I need to get the period. Well, how do we get the period from the graph? Normally, when we have a full graph, like as an example, looking at this one right here, if we have a full cycle and we know for a fact that it's a full cycle, we can't look at these 2 points where we can look at a lot of points, but one of them is to look at if it's unshifted, but which we don't know. We can look at where it crosses the x-axis and get the period from that. However, in a data problem, things could be, you might have only this much data, part of the cycle, and in this given case, that's exactly what happens. We don't have the full cycle of data, therefore we have to look for other ways of doing it. We have to realize that one of the easiest way of getting the period is we have to realize that going from either the maximum to the minimum or from minimum to the maximum, let me cover this up so that it's not distracting. This part is half a period, or this part is half a period. And what I mean by that is going from here to here, this part right there, that's half my period. So in the data problem, we're looking at here it is. Half the period will equal to where the x-axis where my maximum y occurs minus the x where my minimum y occurs. And in our case, it's 13 minus 1 equals 12, but that is only half the period. So therefore, the full period is 12 times 2 equals 24. Now, once we have the period, it's easy enough to get the B value from this definition here. And when we solve for B, plug in period equals 24, B will come out to be pi over 12. That's my B value. Now, to get the C value, in order to get the C value, if you remember what C value, where it comes in, phase shift is defined to be C divided by B. Therefore, if we solve for C, we get C equals phase shift times B. But for that, we have B, but for that we need phase shift. Phase shift we get from the data itself. couple ways of doing it, but again, one of the, because if we had the full graph, that's easy enough to see where this point, for instance, shifts. However, with a data problem, this point may not be so clear. But what is clear is we have to understand that not only when we phase shift the graph, every single point on it gets shifted. And the easiest point to kind of zero in on is the maximum y. So the how the y shifts, maximum y shift is the same as this. So our phase shift could be derived from this shift right here. The question is, how do we find it? By coincidence, it happens to be crossing here. Well, we find it by thinking of it this way: where my maximum should have occurred versus where my maximum actually occurred. And this right here will be the phase shift. Now, looking at our data itself, the maximum y should have occurred at, where does it normally occur? Well, it normally occurs at period divided by 4. If you remember, look back to our basic sine function, the maximum occurs at this point, which is really 1/4 of the whole period. So if you think of it this way, maximum y should occur at period divided by 4. Well, period is 24, we found from before. 24 divided by 4 equals to 6. That should be the x value where it should have occurred. Now, where did it actually occur? We get that from the data. The data, where's the data portion of this? The data portion of it told us that the maximum occurred at x equals 13. The maximum equals 9, the maximum y equals 9, but it occurred at x equals 13. So we plug 13 in for, in this equation, max y should actually have occurred at, I'm sorry, I'll restart. Max y actually occurred at x equals 13. So the difference between where it should have occurred and what actually occurred is the phase shift. And in this case, 13 minus 6 equals 7. That is my phase shift. Once we have the phase shift, from there we can get the C value, because C value is defined to be from before, right there, phase shift times B. B we already know. That is pi over 12. So C will equal to 7 times pi over 12. Well, 7 pi over 12 is my C value. So now I have all my A, B, C, and D values, and I can copy them down in the equation form as y equals 4 sine open paren pi over, I'll bring this a little closer. So 4 times sine open paren pi over 12x minus 7 pi over 12 close paren plus 5. That is the data problem on version 2 test. And I'll zero in case you want to look at anything else here. Okay.